Like I said, I wanted to show you the calculator use for it, but in my opinion, it's just as easy. It's pretty basic calculations in order to do it by hand. All right, so let's talk through this second example here. Okay, how to graph this. So the first thing you need to do if you're dealing with a log is determine, is it a log that's the inverse of a growth model or a decay model? Okay, so what's the unwritten base for a natural log? E, and E has a value of approximately 2.7-ish, right? So that is a value that's greater than 1, so you do have a growth model here. So the first thing to identify is the parent function should fit this model right here. Okay, and so let's go through and see what we have. Is there any vertical shift in this graph? No. So none. Is there any horizontal shift? What value of x gives you a 0 inside here? 2. So that goes to the right 2. Okay. The horizontal asymptote, since it's a log, there is none. But the vertical asymptote is going to equal the horizontal shift. So we get the equation x equals 2 to the right is plus 2. So there's your vertical asymptote. Okay, and then I jump down again to the x-intercept. So if I take my original function and plug in a 0 for y, again, I know my x-intercept is going to be something, comma, 0. So if I take ln of x minus 2, and again, I'm going to write the unwritten base e, just because it helps me when I go in to solve this. Isolate my log. There's nothing to add or subtract outside of this. So I can now convert it into its exponential form. I take my base e to the power 0, set it equal to x minus 2. What is any number to the power of 0 other than 0? 1. So if I add 2 to both sides, I get my x-intercept to be 3. Right, so I can plot that point. Here's my x-intercept. My graph is going to have the same form as my parent function. Again, it does get shifted, but it has that same form. So here's my function, and I can identify the other pieces of information. As my graph approaches, or as my graph moves toward the left, it approaches an asymptote in the downward direction, so it's down to an asymptote. As it moves to the right, it goes up or rises to the right. My domain, again, moves from left to right, so my furthest to the left value is 2. Extends all the way to infinity, doesn't touch either one. And then my range goes from the bottom up, from negative infinity to positive infinity in the y's. And so these would be the pieces of information and properties for this graph. And if I wanted to confirm this on the calculator, once again, I can just go in here. I'll change this to the natural log. The natural log has its own key, second x. Type in my expression, x minus 2. You don't need to put a comma with the base after it because it's its own key. The ln stands for the log of the natural base, ln. And when I hit enter, again, I can either go to my graph and view this to see is it consistent with what I sketched. And you can see that it is. And if I wanted to find or confirm this x-intercept, I can either use the F5 Math tab here, or I can go to the home screen. And because I replaced my function, my y1 function, with the new log, if I just hit enter on this again, it'll give me the new value, which confirms that 3 was in fact correct.